Good day everyone. So today's video I am going to react in our lesson about microprocessor versus microcontroller. So before I start, let me introduce myself. Hi, I am Risa Nacion, a third-year college Bachelor in Industrial Technology, major in Computer Technology at CTU Moalboal campus. So the microcontroller versus microprocessor. The microprocessor assembly consists of the processor, the LEU or arithmetic logic unit, the instruction decoder, and a few registers which are used to store data for mathematical and logical operations. So a microcontroller includes a processor, the LEU, instruction decoder, registers, code storage space, flash memory or RAM, general purpose I/O pins, timers, interrupt controller, serial communication module, and so we have the components of a microprocessor and controller. The CPU or central processing unit, I/O input or output, bus, address bus and data bus, memory, RAM and ROM, timer, interrupt, serial port, and parallel port. So the general purpose microprocessor, CPU for computers, commonly know RAM, ROM, I/O on CPU chip itself. So the microcontroller, a single chip computer, on-chip RAM, ROM, and I/O ports or input or output ports. Example, Motorola's 6811, Intel's 8051, Zilog's Z8, and PIC 16X. So the microprocessor versus microcontroller. The microprocessor CPU is standalone. RAM, ROM, I/O, timer are separate. Designer can design on the amount of ROM, RAM, and I/O ports. Expensive, versatility, general purpose, high processing power, high power consumption. Instruction sets focus on processing intensive operations. Typically 32/64 bit, typically deep pipeline, 5 to 20 stages. So the microcontroller have the CPU, RAM, ROM, I/O, and timer are all on a single chip. Fixed amount of on-chip ROM, RAM, I/O ports. For applications in which cost, power, and space are critical. Single purpose, control oriented, low processing power, low power consumption, bit level operations, instruction set focus on control and bit level operations, typically 8/16 bit, typically single cycle 2-stage pipeline. So technology 2, what is good learning? Students collaborating and discussing ideas and possible solutions. Project-based learning designed around real-world context, connecting with other students around the world on topics of study. Immersing students in a learning experience that allows them to deal with a problem, gaining higher-order thinking skills and pursuing the solutions. So what does technology has to do with it? Technology is already demonstrating how they influence the way we think, learn, and interact. Technology is demonstrating tremendous potential in the way we think, learn, and interact. It helps us shape the new ways in which people are communicating, collaborating, operating, and forming social constructs. So, technology is shaping the way we think, work, and live. New technologies, new learning. They afford us the ability to convey concepts in new ways that would otherwise not be possible. Efficient and effective with other instructional methods. These technologies don't just help us teach the old stuff in new ways. They help us teach new stuff in new ways. So, example of technologies: digital gaming, social networking, and simulations. So, digital gaming of the rules, goals and objectives, outcomes and feedback, conflict or competition, challenge and opposition interaction, purposeful, goal-oriented, role-based activity, and fun. Social networking, Post a profile, photos, videos, chat, blog. Connect with peers through individual bulletin, private groups, pages, and forums. Simulations are analogies of real-world situations according to Prinsky 2001 as they recreate a modeled or modified version of a real-world situation. Evolution of microprocessor. Microprocessor is a semiconductor device consisting of electronic logic circuits, manufactured by using various fabrication schemes, capable of performing computing functions, capable of transporting data or information, can be divided into three segments: arithmetic and logic unit, register unit, and control unit. Von Neumann machine 3K concepts. 1. Data instructions are stored in a single set of read-write memory. 2. Contents of memory are addressable by memory address without regard to the type of data contained. 3. Execution occurs in a sequential fashion unless explicitly altered from one instruction to other. That would be all. Thank